We are always Good afternoon, students. We are so happy to see you here. We will get started shortly. Make sure that you guys have a calculator.
All right, guys, happy Tuesday. Welcome. Hope you all had a fabulous weekend. We're going to start today with the warm-up. So you're going to write your answers on your desk using your whiteboard marker and eraser. Those of you who are joining us from home, just get a blank piece of paper out and write what you think, okay? All right, we're going to see what you guys remember from last week. So if you are given a table, can you find the exponential equation given that table? Yeah, allergies are coming back.
It's either allergies or sucking the life out of me.
Okay, so we kind of talked about this. When we know it's exponential, I've told you it's exponential, then that's your clue that we are multiplying by something. But remember with chapter 7, this gets a little bit, it gets a little bit strange because I don't know. Oh, and I apologize, guys. Oops, it got taken off and I didn't redo it for you. Oh, wonder what I did with it. There's a missing number there. Oh no. I'll work backwards. It should be more than 130. It should be more than 3.6 there, guys. I didn't notice that. And I can't remember.
It was.
I think it was 1.3.
Yeah.
Okay. Oh, I apologize, guys. Sometimes when I undo this, if I change that to 93, how would your answer change? Okay? Because that table wouldn't make any sense if it was 93.6 and then jump back to 121. I apologize. Okay? So again, I don't know what I'm multiplying 72 by to get to 93.6. I don't know that. These multipliers and these numbers are going to get weird. So you have to have a strategy in order to figure out your multiplier. And really the best strategy for these, guess and check works, but the best one is to work backwards. So if I take 93.6 divided by 72, that's where I get my multiplier of 1.3. Now, remember the goal of this is to write the equation. And I've seen 2 equations written. And you guys are going to tell me which one you think is correct. Okay. Those are the 2 families that we know.
Oh wait, no, I wrote it wrong.
Yeah. Be careful, we're multiplying.
Oh, you said you have the y equals mx.
Oh, but no, only one of those is right. So I've seen both of these equations. So which one of them is correct? What do we think?
The second one.
Yeah, the second one. Why did you pick the second one? I agree. This is the one that's correct.
Because the 1.3x plus 72, you're adding. You're not
Yeah.
multiplying.
Very good. So the top one represents y equals mx plus b. That's where I would be adding 1.3 every time, but I am multiplying, which puts it into our category of, it puts it into this category, okay? Not our linear family, it's an exponential family. So it looks like this. Now, for our warm-up today, all of our equations will look like this, okay? Not everything we do in class will look like that, but our equations will look like that, okay? All right. See if you can do this one. Same thing, different table. Okay. Can you write the exponential equation for this table?
Give me that
did. Oh, we're gonna do it in class Thursday. Okay, so you'll have some time.
Alright.
You are good. I really like the strategy that some of you have. You know that the first point is 36, and so you go ahead and you just write it like that first. I like it. Now this multiplier is really strange. That's the one, very good. Don't round it, keep it out. Now you don't have to write out the tables if you don't want to, guys, because we're just looking for the equation. So it's okay if you don't write out all of the tables. Yes, that's correct. Very good. Okay. So your multiplier, again, if you don't know how to find that multiplier, work backwards. What's 38.25 divided by 36? And you should get this strange multiplier. Now, I don't want you to round that because that means something. And we're going to find out what that 1.0625 means. We're going to figure out its meaning later in the class, okay? All right, one of the things I want you guys to start getting used to is having a conversation in your head about these problems. So I look at my table and I notice something about my table. What's happening to the y values? Are they getting larger or are they getting smaller?
Large.
Yeah, they're getting larger. And so to me, when I look at this, I say, okay, I'm going from 36 to 38 to 40. My y's are increasing, which means my multiplier has to be greater than 1. I know that immediately. It's got to be greater than 1. Okay. Knowing that, try this one. It's the same question. Can you write the exponential given in this table?
No.
All right. The conversation that I'm having in my head is about what's happening now. What's happening to my y's at this point?
It's getting smaller.
Yeah, they're decreasing, which means what about my multiplier?
It's not gonna be, bigger than, or it's gonna be lower than 1.
It's going to be lower than 1, absolutely. So when I see that it's decreasing, my multiplier in here has to be less than 1. Notice it's not negative. We're not doing negatives. It's just in between your 0 and your 1. And when you work backwards, your multiplier is 0.3. So you're going to take that 32.4 divided by 108, and that'll give you your 0.3. Nice. That's the kind of conversations I often have, like, okay, what do I notice? How do I put this into my equation? All right. We're going to try one more where we write the equation, and then we're going to switch things up just a little bit. Yeah, very good.
They say we can't chat with them. It's weird.
Okay. All right, nicely done. Walking around, you guys are seeing that you have y equals, we started at 246. Again, I notice, oh, my table is decreasing. I'm going from 246 down to 138. So my multiplier has to be a decimal, smaller than 1. Okay, so 0.75. Okay, on these next two problems, can you work backwards now? So if I give you the equation, can you build the table? Now your table doesn't have to be long, okay? Just go up to, just do term 0, 1, or 2 and see what you've got.
Oh, boy.
Yeah, can you
Just
build a table?
why?
Well, because I do enjoy just a little bit things here. Yeah. So can you build the table working backwards? Remember, working backwards in mathematics is just as important, especially if you're having trouble solving something. Being able to go the opposite direction is a really good tool to use. Very nicely done. Okay, remember, today we're going to be talking about that dialogue that should be going on in your head when you do this. I know that I'm starting at 132. My multiplier is 1.4. So what should be happening to my table? What do I expect to happen to my y's? Yeah, good. They're going to be getting bigger. And so 132 times 1.40, you get about 184 point something. If I take 184 point something and multiply it by 1.4, you get around 258 and some lots of decimals. Okay. All right. Very nicely done. Okay. See if you can do this one. Given the equation, can you build a table?
It's not letting us chat.
I know, I saw that.
I don't know why. I didn't adjust any of the settings. And usually,
What about if you hit, is it sharing the screen? One participant at a time, events, it's so weird, yeah, I don't know. Oh, too
I
bad.
know we were hoping to
Yeah,
chat with your people,
yeah.
and we're not able to chat for some reason.
Yep, that's your 0.
So our chat box isn't coming up. So if for some reason you guys have any questions, please feel free to unmic yourself and ask us those questions.
That is correct. All right, so the dialogue I have in my head is I start at 303, and then I have a multiplier of 0.375. So the dialogue in my head says this is going to decrease. And so when you decrease, your next one should be around 113-ish, okay? And then your next one will go all the way down to about 42 something. So 303, 113 with a bunch of decimals, and then 42 with a bunch of decimals. Okay? All right, nicely done, guys. You can erase your desk. We'll come around and pick things up. People at home, you can put your warm-up paper away, and you need what you're doing for today's lesson. So it'll look like this. And I'll come around and give. Nice. Good job on the warm-up. That means you guys are, I'm really excited that you guys are getting this. Love it. All right. Believe it or not, guys, we are halfway through chapter 7 with 713. We only go up to 716. And so this marks halfway through, which means on Thursday, we're going to do 714. So we'll be a little bit ahead of halfway. We'll take spring break. When we come back, we're going to finish chapter 7. That's the last week of March. We'll do all of our assessments. And then it's like, it's a race to the end. Okay. We'll finish up chapter 8. We started talking about finals. Whenever we start talking finals in our Algebra 1 team, We know, ooh, it's getting close. So don't worry, we'll finish chapter 7, but hang on, we're gonna be hitting the end quickly here. So 713 is all about one story, but as we go through this story, here are the questions that you need to really think about. How does it grow and how does it start? Notice those questions have not changed at all since chapter 2, okay? We are always talking about where things start and how they grow. It doesn't matter, okay, if it is a linear, exponential, quadratic, that's what we're looking at. Yeah. Okay? The question that might be different and that what I want you guys to be focused on is this one. This is where we're going to really look at today. How can a rate be written as a percent and as a decimal? So we're going to talk a lot about, if I give you a decimal, can you convert it to a percent? If you're given a percent, can you convert it to a decimal? That's really what we're going to focus on. But how does it grow and where does it start? It's all built in, okay? All right, today is going to revolve around this story. Your grandmother gives you $1,000, and like the responsible person you are, you're going to invest it. You're going to save it for college, okay? And so you now have a choice. There are 2 different accounts that you could put your $1,000 into. Account number 1 is a bond. You go to the bank and you buy some bonds, and they will pay you 8% simple interest. All right, we're going to really focus on what kind of account is this, and then what does this mean? So we're going to look at that one first. So bonds with simple interest right here. Okay, we have a lot of questions to answer, but what I want you to focus on is the table. And I want you to tell me, just like on our warm-up, what is the pattern? Now, here is my hint to you. This could be arithmetic and it could be geometric. So if geometric doesn't work, try arithmetic, okay? But how are you building this table? Does it help if the lamp is on?
It shows well
No,
either
okay.
way. Either way. What's that?
Oh, nice. Yeah. Now, again, you got to have that dialogue with yourself because you're looking at 1,000, 1,080, 1,160, 1,240. What clue in this table tells me that it's not geometric, meaning I'm not multiplying, that I am adding? What's the clue that I'm adding? Yeah, what do you think? Yeah, there's no decimals. Look at this. I'm adding. Clearly, I'm not multiplying because notice every table I gave you in the warm-up had a bunch of decimals. Look at that. That's so nice. Bunch of .00s. So if I'm adding, what is it that I am adding? Yes, $80. So let's fill in the $80. And when we get to here, we're at $1,320. Okay? All right. Now we can go answer some questions. We're not going to answer all of these questions today, guys. And so what I want you to focus on is just question A. You invest your $1,000 and we put it into a simple interest account. How is it growing? Well, simple interest grows by adding. Now, the $80 is what we're adding. Why $80? Is it because you went into the bank and the teller that's helping you says, "Oh, I like your hair. I'm going to give you $80. Yeah, what do you think, Kellen? Why?
It's the 8%.
Yes. As much as I would love it to be about your hair, that's not how things work. Okay? It's this. They're paying you 8% of your initial deposit. And so that's where that $80 comes from. So it'll look like this. You took your initial deposit of 1,000 and you're taking 8% of that. Remember, in mathematics, the word of means what? What do you do when you say of? Other one. Yeah, multiply. Of means to multiply. Okay, so if I take 1,000 times 8%, that's where the $80 comes from. It has nothing to do with your hair. Bummer. Now I'm gonna define each one of these part of this equation. And so what I want you guys to think about is, what does the 0.08 mean? What does the 1,000 mean? All of those good things have meanings. And so the 0.08 represents your interest rate. And that is the thing I wanted you to really think about, the rate. How can you write the rate as a decimal? Well, there it is. There's your first attempt at that, okay? The 1,000. The 1,000 represents your initial deposit. Okay, that is your initial deposit. And the 80, okay, the 80 represents that you're getting $80 every month, or the money earned every month, every year, sorry, it's money earned every year. That's how you interpret simple interest. You're adding, and what you add depends on what your interest rate is. I was gonna say, can they see that? Oh, look at that. They can. It's actually not too bad. Yeah, love it. Okay. Okay. So we now have a dilemma because we have another account that we can invest in, and you have to decide which account. So let's look at the second account. The second account belongs to a credit union, and you are getting 8% compound interest. So different word, it's no longer simple interest, it's compound, and they pay 8%. Same interest rate, but there is something different. So let's come down here. Accounts with compound interest, but again, we have a lot of questions to answer, but before you answer those questions, what is the pattern here? See if you can figure out the pattern in this table. What is happening? I agree with you, Dustin. You are multiplying by something. Absolutely. What do you get away?
1.8.
Ooh, you're close. Try it in your calculator and see. You're really close. Okay. I like the way you're thinking about it.
Because it's the same interest, and he's putting in the same thing, so it'd be 80%.
Be careful. It's like 80%. It's 8%.
Or 8%.
So think about how you write 8% and then do exactly what you just did. Okay. All right. So think about, Dustin has already figured out you're multiplying. What are we multiplying by? Yeah. 1.08. I'm multiplying by 1.08. So when I multiply, I get 1,360 and 49 cents. Okay. So how compound interest works is that when you do simple interest, you just take your $1,000 and you put it in the bank and you just let it sit there, and they calculate your interest on that very first deposit, and that's it. It doesn't matter what else you put into the bank, it's that initial deposit. Compound interest says, oh, look, you have $1,080 in the bank after year one. We're going to take interest on that. And then we'll put it into year two. Oh, year two, you have 1,166. We'll take interest on that and then give you money. Whereas simple interest, you only get that interest calculated at the very beginning. So let's answer some questions here. All right, explain how compound interest is calculated and how is it growing? Well, compound interest grows by multiplying. Okay. and that's what I'm multiplying by. I'm multiplying by 1.08. So again, we have to think about what is happening with these numbers. You got to know. And Dustin, you pointed out that you knew there was 8%. So are you surprised to see that 0.08 in there? Okay. Now Dustin said we get 8%. So exactly as he said, that 0.8 means you're getting 8% more each year. So what does this 1 mean? Well, how come I didn't multiply just by 0.808?
Because that would be making it go down.
Oh, it would be making it go down. So that 1 is important because we're actually getting money. And so you have to think of the 1 as that's your initial deposit. That's how much you are getting to keep. So the way I kind of think about it is that you get to keep your original, and then you get 8% more each year. That is how you interpret those two numbers. The 1 means you're keeping the original, that's the $1,000, and the 0.08 means, oh, I get to get 8% more every year. Okay, we are not going to answer part D. You've already actually kind of answered that one, but I do want you to answer part E. And this is, okay, we've now done the math. Which account are you going to put your money in? So answer that last question. Which account are you going to choose? Are you going to choose the bonds at simple interest or the credit union at compound interest? See what you got. Okay, so we've done the table and we figured out the patterns. The next step is to see a picture of what these two accounts look like. So on the next page, what you're going to do is you are going to be graphing all the information in both tables. So table 1 is our plus 80. And you need to graph all 4 points in that table. And then the second table is your times 1.08. And you have those two. Now the scale on this guy, you're going up by 50s. So some of them you're going to have to kind of guess, okay? All right, see if you can graph the information on the graph. Graph the tables. So weird. I wonder why.
Yeah, I don't know why.
What's wrong?
Because I seriously haven't done anything with it. Like, but we only have, oh no, we have, gonna have to make the settings different for after spring break.
Yeah. That's a little off. There's 50. You kind of have to guess where those pieces are. Right, you guys got it. 1240 is just under 1250. 1320 is just over 1300. Okay. It'll look something like that. Remember, your y-axis is your money and your x-axis is your years. Okay. Now, because we're back to living in the world of y and x and no more t of n and n's, we're no longer in sequence mode, so it's okay if you guys connect the dots. Okay, and I want you to connect the dots so you can see the difference between your two curves. They're your two graphs, I should say. Oh,
You'll be fine.
well, you're almost. So close.
Almost.
All right. So what I want you guys to do is I want you to graph them, connect the dots like you normally do. What I'm going to show you guys is actually what's happening in the bank. Okay, so you don't have to worry about what is truly happening. I just want you guys to see what is. So the way this actually looks is this. You put your $1,000 in the bank and it sits there. You put your money in January 1st. On December 31st, the bank says, hey, we owe you some money. Here's your interest. Here's an extra $80. And all of a sudden your account just increases $80. Then that $1,080 will sit there for another year. And then December 31st, oh, the bank gives you yet another $80. And it keeps doing this. You actually don't get your money instantaneously. So what does that look like to you guys? What does that picture look like? Yeah. We got some steps going on, or some stairs. This type of scenario or question is actually what's known as a step function. And you're going to see that word step function. Don't worry, you're not going to be tested on it. We just want you guys to see it. What I want your graphs to look like is this. Notice when we add 80, you get this nice line. When you multiply by 1.08, you start to get a curve. How many years does it take before the exponential curves away from the line?
Over.
Yeah, just about 3 or 4. So you can see the first two, they're actually the same. And all of a sudden, at year 3, 4, we start to see that branch. And the line will just keep going this way, but that red or that exponential keeps going up more and more. Okay, so now we've done the story problem. We've looked at tables, we found patterns, we've done a graph. What's the only thing left for you guys? Good, yeah, the equation. That's the only thing left. Okay, so flip this over and you guys will see, you can see that word step function in there. That's where it comes from. Again, you don't need to worry too much about it, so you might see it. So we're going to do exactly what Kellen said. We now have to write an equation for both of these. So let's see what we can come up with. I'm going to try it this way. So let's do the simple interest equation and the compound interest equation. Okay, see if you can write the equation for both tables.
You switched it up.
I did. I was thinking maybe for them it might be easier if I do it that way so they can, I'm not going back and forth.
Yeah.
So much. Okay. One of these will look just like our warm-ups. The other one will not. Remember, 2 different tables, 2 different graphs, 2 different equations. See what you can come up with. Yeah. You got what you were doing to each one to build that table.
I'm sorry, I'm waiting. I keep checking my this.
One second, get yourself.
And this one's
Right.
Yeah.
Beautiful. All right, guys. So simple interest
Excuse myself there.
was where we were adding 80. So if I'm adding, it's arithmetic, which means it belongs to the linear family, which means it's y equals mx plus b. And all of you remember that you're adding 80 and you started at 1,000. Nicely done. Sometimes students will say you are adding 1.08 because they get, oh, it's multiplying and adding the same thing. Be careful, you're adding 80. Now the compound interest was where we were multiplying, which means it's geometric, which means it belongs to the exponential family, which means it looks like our warm-up, where we started at 1,000 and we're multiplying by 1.08. Look at the difference between those two. Means two different things. Okay, last of these kind of questions, and we're going to mix it up. So we're going to skip part B, and we're going to try part C. Okay? So part C is what is in the account. We have two accounts. How much money is in each account after 20 years? Okay? So use both equations. See if you can calculate how much money is in the simple interest and how much money is in the compound interest. Now you just made your equations, so make life easy for yourself and use them. That's why we use our equations, okay? Think about, you have 20 years. Where are you going to plug in 20? Now notice in both of those equations where does the 20 go, okay? One, you're just multiplying 80 by 20, and the other one, you're raising something to the 20th power. That makes a big difference. Yeah. Okay, very good. Very good, you guys. Is anybody surprised that the compound interest is almost double? 20 years, okay? Grandma's really going to be excited about that 20 years. So on the first page, if you chose the compound interest to put your money in, compound interest is always a good way to invest your money. You're always going to get more in the long run if you're comparing it to simple interest, okay? So remember, you're just plugging in 20 and solving for those, and you should get about double. So what does this mean for you guys? Well, in Algebra 1, you're going to get these money problems, and we will always compound our interest yearly, meaning the bank will pay your interest one time a year. However, in Algebra 2, you're going to see questions a lot like this where it says, oh, you get it compounded quarterly, which means you get interest 4 times a year. What happens if the bank gives you compounded monthly?
Oh, God.
How many times a year will they pay you? 12, because there's 12 months in a year. Now, what do you think would happen if you got interest compounded every second of every minute of every hour of every day?
Wow.
Woo! There is such a thing, and this is where you guys are headed in the next few years. So in Algebra 2, you learn how to do that. You learn how to compound your interest, okay, more frequently, like every hour of every second of every day kind of thing. And you get to learn a brand new number. It's called the number E. It's kind of like pi, okay? Then look at these lovely equations you guys get to learn. This is what happens if you deposit $1,000 not just one time, but what happens if you did $1,000 a month for 20 years, okay? This one is loans. What happens if you take a loan out from the bank? What happens if you borrow money from the bank? And here's what I like to point out to students, especially in Algebra 1. That's a negative exponent in that ugly looking equation. So we do make you learn negative exponents for a reason. We don't just make them up to torture you. They actually exist in real life things, okay? But this is all algebra 2 stuff, okay? You're gonna get there, but just know what you're doing here right now is building to what you're going to see in just a little bit. Okay. What you need to do is you need to turn your paper over to the blank side. Okay? And we're gonna end with kind of just a way to wrap this guy up. Now, I'm gonna start with the same story. You were given $1,000 to invest, $1,000 to invest, but I'm gonna change the story, so you have to tell me what are the multipliers. Okay, so we saw that if you got 8% compounded annually, our multiplier was 1.08. So here is your new challenge. You take your $1,000 to a bank, and this bank says, oh, I'm sorry, we can only give you 5% compounded interest. What would be your multiplier? This is what you're trying to find for me. What would go right here if you only got 5%? And you don't have to write out the equation each time. I just wanted to set it up so you guys could see it. It is. Yes, yeah. Okay. Yes. Now, be careful because that means I'm losing because it's a smaller than a 1. So how do you make it bigger than 1? Nice. All right. If you have a hard time figuring out what your multiplier is, I'm going to give you the logic behind it. So here's the logic. You get to keep your 1. Okay? That's what's in parentheses. Now you also get to add on whatever rate you're getting. So if I'm getting 5%, I get to add on 5% every year. If I'm getting 10%, it's 10%. So how that looks is, well, if you're getting 5% every year, 5% written as a decimal is 0.05. Add the two together. That is now your new multiplier. Okay. Let's say there's a new bank in town, and this new bank is trying to get customers. So you take your $1,000 to this bank, and they say, we have got a deal for you. We will give you 15% compounded annually. What would be your multiplier? What would your multiplier be if you had 15%? Oh, I cannot trick you guys. So think about 15%. Remember, if you get stuck, think about, okay, my 1 is there, because I always get to start with my deposit. 15% written as a decimal, looks like 0.15. When I add it, my multiplier is 1.15. Okay, I'm going to mix things up just a little bit. I'm going to give you what actually banks give you. Sometimes it's not nice. Like my mortgage rate is like 3 1/8%. So sometimes it's not these nice numbers. So what happens if you go to the bank and they give you 3.5%? What would be your multiplier of 3.5%? Go back to this and see if you can kind of figure out, reason your way through 3.5%. It's weird, I know. But you gotta know how that one works. It's weird. Yes, sir. So if you write it like that, that tells me that's like 100
Or we could just go.
1,000. So I know this is a weird one, guys, but here's what we really need you guys to see is that how do you convert a decimal or a percent to a decimal? Well, I have my percent at 3.5. Move the decimal place. Yeah, you're moving the decimal place, and the way you move it is, remember, it's out of 100. So you're just dividing by 100. Percentages are out of 100. So this means 3.5% is 0.035. That's how you interpret that. So when I come over here to my, this is what I'm doing in my head. This is the logic part that I'm doing in my head. Okay. Then this becomes 0.035. And when I add them, my multiplier is 1.035. That means I'm increasing by 3.5%. Okay, it looks like this guy. 1.035. Okay, I want you guys to try one of those on your own. What happens if the bank gives you 6.25%? What is your multiplier going to be? Think about this kind of logic. Think about what I was doing off to the side. That's kind of what's going on in my brain there. Divide by 100 and see what you got. This one should look familiar because this one was the one from the warm-up where I said, ooh, looks weird. You did. Fantastic. Really, really nice. What do you think?
Okay. Make sure that you are moving decimals when having your zeros when you need them. I'm going to try on your calculator.
So, I know that 6.25 is going to be 0.0625. When I divide by 100, that's what it looks like. So, if I'm increasing 6.25%, that's what it looks like. And that's what we had talked about on that warm-up. I said, don't round that because it means something, right? All right, 2 more, guys. I take my $1,000 and I'm going to be what's called an aggressive investor, and I'm going to put my money in the stock market. But oops, the stock market crashes and I lose 8% of my money. What will be your multiplier if you lose 8%? Okay, I'll come back to my logic part here in a minute. I lose 8% of my money. So what's your multiplier? You're close. But you'll see what in just a second, the logic, okay? You're close.
Oh, wait.
I know, this is unfair. Okay. All right. I want you guys to think about this side. What I'm doing over here is kind of what I'm doing in my brain. Like, this is what I'm thinking about. So the original amount, I keep my 1,000, right? I'm depositing 1,000. I don't change that. So the 1 represents the 1,000. But how do you show in this equation that I'm losing 8%? What do you do when you lose something? Are you adding it, subtracting it, multiplying it, or dividing it? Okay. I'm losing 8%. So here's what it looks like. I'm losing 8% of my money. So what's 1 minus 0.08, or what's 100% minus 8%? Think about 100 minus 8. What would you get?
92.
92. So that means I'm keeping 92% of my money, but I'm losing 8% of it. So when you talk about multipliers, you're always talking about what are you keeping? Okay, how much did you keep? All right, I'm gonna go big or I'm going home. I mean, like I'm going back to live in my parents' basement home because I invest my $1,000 and I lose 35%. Ooh, ouch, what would be my multiplier? If I lose 35% of my money, what is my multiplier? Yeah, after this, I'm gonna have to go live with my parents. It's gonna be bad.
You said 35?
35%. I'm losing 35% of my money. Notice the way this part works. This means you're
No,
getting
that's how
interest
you
every
can
year.
do the
That
next
means you're
lesson.
losing. So you have to subtract
To with
your interest rate. So you're taking one. Yes. So you'd be taking either 100 minus 35 to your percent, or taking 1 minus 0.25. Okay. So right here, when I'm looking at this logically, here's what I see. My 1,000 gets to stay. I'm keeping my 1,000 as my deposit, but I'm losing 35%. So when I take 1 minus that, or 100% minus 35%, I get 0.65. Ooh. Ouch. That was a rough one to lose all that money. All right, these notes are for you guys to keep because you can now use them to help you with review preview 713. If you haven't done checkpoint 6A, please do that, okay? I know some of your grades, people were worried about it. If you haven't done it, do that. Make sure you do that by Thursday. Anything else I'm forgetting? Awesome. People at home, thank you for joining us today. We'll see you on Thursday. Oh, and people at home, Thursday you need 100 pennies, or you need 100 of something that has 2 different sides. So you can even take a piece of paper, color one side, and leave one side blank. That would work. Okay, but you need 100 of 2-sided things.
Poker chips, playing cards, that kind of stuff will work too. So
Yep.
be creative with this. So you will have that opportunity. If you have any questions, please reach out to us. We are grateful that you have made it here. Enjoy the rest of your day, and we will see you on Thursday.
I have a quick question. I have a quick question about what time after spring break we'll be meeting.
We will still be going 5th hour, and that would be the 12:30 to 1:30 class.
Oh, okay, 5th.
Oh, wait,
Let me get my.
that would be the 12:20 to,
Let's see here.
is it
It would be, 5th hour would be 12:20 to 1:10.
12:20 to 1:10? So we will
Yeah,
change our Zoom link to 12:15
Yeah.
to 1:15. So that is when everybody will attend.
but remember that's after spring break
Yes.
for those of you. Okay.
Yep.
Thank you.
Yeah. Thank you. Have a great day.
I kind of forgot that we were changing.